Okay, this lesson is 7.1 part 2 on just Euler's method, right? So Euler's method is actually really interesting because you have now these slope fields that you saw in the first part of 7.1, and slope fields are usually used to guesstimate what the original function would look like given a really complicated slope field. So this is not recommended to be used on something that you can actually separate and solve. This is something that you really can't solve. So it says usually start with a differential equation that might have both x's and y's. It's complicated so that you can't really separate them and get an actual answer. But Euler discovered that when you have the first derivative of this differential equation, and you're able to get at least one solution, one point on this possible graph, you're then able to use his method, his formula, to get multiple points along that actual line that you're looking for. So it's actually kind of amazing that even though you're not able to solve for the actual equation, through his method, you're able to find other solutions, you're able to find other points on that line that you can't solve for. So I thought that would be worth kind of discussing, okay? So it says that here are some steps, right? So your formula is this, that y sub k equals y sub k minus 1 plus h times f prime of x sub k minus 1, y sub k minus 1. So, wow, that's a lot of things. First things first, you want to figure out where your starting point is. They usually start with a point given to you, right? So here's a point given to you. And how many steps does it need for you to take to get to the point you actually are solving for? So given a point, I want a new point. Like given a point at x equals 1 and y equals blah, blah, I want the solution at x equals 2, for example. So, and then through how many steps are you going to get there? So the number of steps tells you, right? Number of steps to actually create this h for you. So it's how far apart you are from your given value to the new value that you're trying to estimate. And of course, the more subdivisions, just like always, the more accuracy you have, but it's also a lot of work. All right, so we're gonna try to compute this, but I will be pretty honest with you, we're not gonna finish this. So you can actually see the textbook for the actual answer to this problem, all right? So it says, find the solution when x equals 2.4 for x equals 1, between x equals 1 to 2.4. So the initial value given to you is x equals 1 and y equals 1.59. And here is your derivative, okay? So sometimes it's a little easier to make a t-table to see what we're actually doing here. What we're actually doing here is we start at 1 and we're gonna go all the way down to 2.4. I know my answer is 1.59, that's all I know, okay? So then what do I know next? I need to figure out what my h is, how far my increments are, how many steps to take to get there. So h is equal to b minus a over n. We said n equals 10. So then this is 1.4, 0.14. So that means I need to go from 1 to 1.14, 1.28, 1.42, all the way to 2.4. That's how many steps it'll take to get there. And of course, because we're taking 10 steps to get there, my accuracy is going to be pretty good. All right, well, cross my fingers, it's going to be pretty good. Okay, all right, so here's your y sub 1. Y sub 1 is equal to, the first y is 1, right? So here's my first guess, my first solution to the equation here. So y sub 1 equals my old y was 1.59, plus my h of 0.14, and f prime of the old number. So that means plug these old x and y into your derivative. So my derivative is 1 plus y, so y is 1.59 minus 1 squared, right? And again, this is all kind of calculated work, so we really don't expect you to do this by hand. So we're gonna go ahead and figure this out. So 0.59 squared, and then close parentheses. I get my first y value to 1.778734. So 1.778734. It's a lot of decimals, but of course, the more decimals you keep, the more accuracy you have. Golden rule is to keep to 3 decimal places. Okay. All right. So then now using that, I can estimate my next y sub 2. Okay, so next y sub 2 is, again, following the formula, is the old y, so 1.778734, and then plus the h, 0.14. And now go ahead and plug that into my derivative. 1 plus this new y, 1.778734 minus 1.14 squared, and close parentheses. All right, so 4 parentheses 1 plus 0.778734 minus 1.14 squared, close your parentheses. My next y is 1.975951357. So 1.975951357. And again, you just keep following this formula until you get the y value at 2.4, and that's what you're solving for. Okay, so yes, it's a lot of steps, but it's actually really cool because you're able to get these answers without actually having the actual equation. One last thing to really keep in mind is right here in this box, it says if the initial solution is 1, 2, and you want your solution to go backwards, going towards the left-hand side, then your h will be a negative number because you're moving your increments towards the left to inch towards your answer that you want in the negatives instead of the positive. So if you're going towards the positive side, your h is going to be positive. If you're going towards the negative side, your h is going to be negative. Okay? All right, that's it.